I had to move the next exam because I didn't realize that April 7th is a state holiday in North Carolina because it's not in Ohio. And I had the exam scheduled for that day. So what I decided, I didn't want to make it the Wednesday before, and I didn't want to make it on a Monday, especially if you celebrate the holiday. So what I did was I made it that following Friday. So instead of the 7th, it will be the 14th. And we'll just cover more material. I don't think I'll cover, I was thinking of moving 5.1 and 5.2 there, and then 5.3 and 4. But what I'll do is this will just be 5.2, 2, whatever I can cover, 5.4. Probably just 5.1 and 2, but depending on how fast it goes. But whatever we cover in chapter 5 will be this week. And then we will review, and your exam is May 8th at 8 a.m. Any questions on that? So I did move it a week. Any questions?
Do you know how many questions will be on the final?
No, I don't. I will look it up and see what, because it'll be similar to my other finals, so it won't be longer than that. But I will look it up. It will be similar to the tests where we have an in-class test and a take-home portion. And the take-home will be up before, so it'll probably be up the 23rd. And it'll be due, I think I went to the 11th. What else? The in-class portion is usually about an hour long, so it won't be too much longer than your regular exams, but I will look that up and let you know. But we do have an exam before that. But it's usually about an hour, even though your exams are, I think they're 2.5 hours long. Any questions? And we'll review just like we review for every test, we'll review for the final. Okay. I think we have some formulas first before we do that. Don't forget your project is due this week. Is there any questions on it? Okay. The in-class portion of the exam, well, it was graded a while ago. I think I might have even emailed this out, but I don't know. But it was worth 50 points. So 50 to 45 was an A, 44 to 40 was a B, and 39 to 35 is a C. There were 28 A's, 5 B's, and 2 C's. Usually the take home students do better than the in-class, hopefully, because we did half the problems in class. So these should stay about the same or move up. I think there's one person took it, but I didn't get to grade it yet. And then there's 2 others that are not on here. There were 10 perfect grades. So I thought that was awesome. I think it's one of the harder one tests. I think the next section, chapter 7 is definitely easier. Chapter 8 and 9 are just story problems using what you learned from chapter 7. So I think whatever you have on your last 2 tests, you're probably going to keep getting those grades. I don't think the material is going to get harder. And chapter 5 is definitely easiest. That's why I like to leave it last. So then it's like you can just breathe and you have all your material from your other classes. Okay, section 7.1. We're working with derivatives. Now you learned the long version of the derivative. The limit, it's h approaches 0. Now we're going to learn a shortcut. Remember, you take the derivative for the slope of the tangent line. Relative max or min values. Marginal cost, revenue or profit. What it does when you have a graph, it finds all the highs and lows. And so that's your relative max and mins. It finds these highs and lows. Now notice this one has 2 high values. There's 2 relative max. There's only 1 absolute max. So I think that's in chapter 8 where you find the absolute highest value. So that's what's, these 2 would be relative max. This one's an absolute max because it's the highest. And then this would be a low. And notice this is where the tangent line is horizontal. So when you're finding your max and mins, you're taking the derivative, which finds the slope of the tangent line, and then you're setting it equal to 0 because that's where it's horizontal. So to find relative max and mins, you take your derivative, you set it equal to 0, and that'll tell you where all the highs and lows are on the graph. There's a few different notations that you'll see for the derivative. I usually use this one, the prime symbol. But the book has a few different ones. The derivative of y with respect to x. And then they also have, I know there's one on my math lab that's written like this one. It's the derivative with respect to x, and then it writes the function out here. And the last one, the derivative with respect to x, and then it puts the function. So those are different things you may see. For those all mean to take the derivative. So all these values, or if it asks for the slope of the tangent line, the relative max and mins, marginal cost, revenue, or profit, all of those mean to take the derivative. The first rule is called the constant rule. If the function equals a constant is just a number. Now this symbol, this means K is a member of the real numbers. And I think we've used that before. Then the derivative is 0. So any constant, when you take the derivative, it's 0. If f of x equals 5, the derivative is 0. Because your function is constant, it's a horizontal line. It's not increasing or decreasing. So the derivative is 0. Square root of 2, it's just a number, 1.414. Derivative. 0. It was Pi Day the other day, 3.14. It's just a number. Any questions so far? Let's put some variables in there. There's what's called the power rule. If f of x equals x to a power, where n is any real number, now what you do when you're taking the derivative of just like the power rule, you bring this value down, n x to the n minus 1. So you multiply and then you subtract 1. Now, if there's a number in front, like our constant, then the derivative, this n gets multiplied times the k. So you just, if there's a number attached to your x, you just multiply that exponent times it. Okay, let's try a couple. So multiply and then subtract 1. 3 times 5. 15x, and then subtract 1 squared. There's a couple rules, and then we'll do problems with everything put together. So multiply and then subtract 1. Two times 3 is 6x, and when I subtract 1, it's to the first power. You don't have to have the 1 there, it can just be 6x. Try one more. Okay, notice there's no number on the exponent. Remember, when there isn't one, it's a 1. So when I take the derivative, 1 times 4 is 4x, and when I subtract 1, it's going to be x to the 0. X to the 0, or anything to the 0 power, is 1. So when it's a 1, it's just going to leave the number in front. 1 times 4 is 4, x to the 0. Just think of it as dropping off, because it's a 1, and 1 times your number in front. Just need to be careful when it's just x. What would the derivative of x be? Anyone? You can type it in the chat. When there's no number in front of your x, what is it?
1.
A 1. So then this would be 1, because we'd have 1 times 1 is 1, subtracting 1, x to the 0 drops off. You want to be careful, because I have students who definitely know all the rules, but then when you get to that one, because there's no number in front, they get a little stuck. And so just be careful. Remember, when there's no number, it's a 1 in front or in the exponent. One more rule, the sum or difference rule. If f of x equals u of x plus or minus v of x, then f prime of x is just the derivative of those. All it's saying is you can take the derivative of each term separately. So if we look at number 1, this tells us that we can do each term individually. Terms are broken up by plus and minus signs. So there's 1, 2, 3, 4 terms here. So do each one individually using the rules that we just went over. 3 times 12, 36x subtracting 1 squared. 2 times a -8, -16x to the first. Of course, we don't have to show the 1. Plus 1 times 7 is 7, x to the 0 drops off. And the derivative of a number is 0. Now, I like to put this for a while, or recommend putting it, so then you remember where the 5 went. Or put plus 0 here. And you can even put x to the 0. But let's try another one. Number 3. Yes. Button files. So go ahead and take the derivative of that one. Getting 12x cubed minus 18x squared plus x over 4. And then the 5 goes to 0. Is everyone getting the x over 4? There's a couple ways we could look at that. This part. X squared over 8 is the same as 1/8 x squared. This just uses less space and less ink to write it this way. So then when you take your derivative, 2 times 1/8 is 2/8 x to the first, and that reduces to 1/4 x, which can also be written as x over 4. Both of these are correct answers. My math lab will take both of them. It will not take this. I think it will say your answer is not wrong, but it's not reduced or something like that. You need to still simplify. But any questions on that part? So that the reason it's 1/8 is because remember when there's no number, it's a 1. So then the 1 could have been here also. Any questions on that one? Okay, try number 5. So taking the derivative, we have two terms. 3.5 times 6 is 21x. And then when we subtract 1, we get 2.5. 0.5 times a negative 10 is a negative 5. And when we subtract 1, we get a negative 0.5. Most of them, my math lab doesn't mind if you leave a negative exponent. But if they want positive, you just move it to the denominator. 21x to the 2.5 minus 5 over x to the 0.5. Only the variable has the negative exponent. Only the variable moves down. I would accept both answers. My math lab, if it says to make sure it has positive exponents for your answer, then you would have to do this, but in most cases it takes both. Any questions? Number 7. Three-fourths. Square root of x. We didn't learn that. But the square root of x can be written as an exponent. One half. Go ahead and take the derivative. I'm gonna write the steps out. 1/2 times 8, so it's 8 times 1/2 x, and when we subtract 1, we get a negative 1/2. Plus 6 times 3/4, and subtracting 1, we get a negative 1/4. Eight times a half is 4 x to the negative 1/2 plus, let's see, 6 times would be 9/2. Any questions on that one? Any questions? Number 9. Now make sure if you have questions, ask, or make sure you're trying them before I do them. That way, it looks completely different when you go home and do it on your own. It seems easy. So 10 to the negative 3. Now on this one, when you have negative exponents, you need to be careful. So negative 3 times 10 is a negative 30x. But when we subtract 1, it's a -4. A lot of times what happens is you're so used to the number going down by 1, you put a -2. So be careful of that. -3 minus 1 is -4. Next one, -4 times 5 gives us a -20x. When we subtract 1, we have a -5. This one doesn't have a number, so it's a 1. 1 times -8 is a -8. And then we have x is 0, which drops off. Any questions? Let's do 12. Or maybe that was 13. Yeah, it is. So we'll do 11 and then 13. We didn't learn a fraction. Well, we learned fractions, but not a variable in the denominator yet. Just like this one, we moved it down to make it positive. We can move these up, which makes them negative, similar to the problem we did before. So if your variable is in the denominator, until we learn other rules, we can bring it up. And when there's a number, it's a 1. So this would be 7t to the -1 minus 5t to the -3. And then we can take the derivative. So sometimes, just like the square root, we have to rewrite before we take the derivative, especially until we learn more rules. -1 times 7 is a -7t, and I'm subtracting 1, so it makes it a -2. -3 times a -5 is a +15t. Subtracting 1 makes it a -4 in the exponent. Any questions on that one? Okay, try number 13. I'm going to rewrite them. So the x to the 4th, I'm going to bring up 6x to the -4. Minus 7x to the -3 plus 3x to the -1 plus the square root of 5. So all I did was I took the numbers in the denominator and moved them up. And then you take the derivative. -4 times 6 is a -24x to the -5 plus negative times negative makes that a positive 21x to the -4 minus 3x to the -2, and that goes to 0 because the square root of 5 is just a number. Any questions on that? Number 15. And there's quite a few problems on 7.1. Simply because everything looks so different. There are 19. But you want to make sure you practice all of those before we start the next 7.2, because it's just going to build on them. Go ahead and take the derivative. Negative times negative is a positive. Half of 10 is 5x, and then I'm subtracting 1. So it's going to make it a negative 3/2. So 2. Negative times positive makes us a negative. 2 goes into 8 4 times 3, so it's a negative 12x. Subtracting 1 is a negative 5/2. Is that what you got? Or if you didn't, any questions on why you didn't? For this 12, 8 times 3/2. If you want to multiply first, you can multiply cross. 24 over 2 is 12. Any questions? $17. So the fourth root can be written as, remember, it's a fraction part of your exponent, so it would be 1/4. But then it's in the denominator, and I didn't learn a fraction rule, so I need to move it up. And now I can take the derivative. So a radical is the denominator of your exponent. And then to move it up, it changed the sign of the exponent. Negative 1/4 times 6 is a negative 3/2. X subtracting 1 is a negative 5/4. Any questions on that? Um, 19. Now we are gonna learn a quotient rule where we could take the derivative of this. But because we haven't learned it yet, we need to divide x into both parts. And you can only do this when there's one term on the bottom, and then you divide it into each term on the top. Remember, when you're dividing the same variable, you subtract your exponents. 3 minus 1 makes this x squared. And then this one I'm going to bring up so that I can take the derivative. Any questions on rewriting it? I'm taking the derivative. When there's no number, it's a 1. So 2 times 1 is 2x to the first power. Minus 5x to the negative 2. And the 1 here doesn't have to be here. Any questions on that one? Should we try number 20? I think we should try 20, especially since it's fractions. G of x cubed. I'm going to rewrite that radical as x to the 1/2. So this is the same as x cubed over x to the 1/2 minus 4x over x to the 1/2. Three minus a half. If we get a common denominator, it's 6/2 minus 1/2, which is 5/2. So 3 minus a half is 5/2. X to the 5/2. Sometimes my math lab will allow you to put a decimal, and other times it wants the fraction. This is a 5. Here we have a negative 4 x. 1 minus a half is 1/2. So just rewriting them, you get this. Then you can take the derivative. Five halves times 1 is 5/2 x. Subtracting 1 would be 3/2. Minus half of 4 is 2x. Subtracting 1 is a negative 1/2. Any questions on that? We'll stop there. So all the ones that aren't asking for slope of the tangent line and everything, we've done all of those. So you make sure you do all the basic ones here. Let me see what numbers they go up to. 11. For Wednesday, I recommend trying My Math Lab, section 7-1, 1 to 11. The other parts we have not covered yet. I mean, you probably could still do them. But at least these, so you're comfortable with the derivatives. So then when we add the story problem, derivatives are easier. Is there any questions? Okay. If you don't have any questions, I will see you on Wednesday. Have a nice day.